Solve the following simultaneous equations. So we've got 3x plus y is equal to 13 and 2x plus 3y is equal to 4, and then we've got a b here, 5x plus 3y is equal to minus 1, 7x minus 2y is equal to minus 20. Now there are several ways of solving simultaneous equations, but in this one we're going to look at the method of elimination. So using the method of elimination, and you can decide whether you're going to eliminate the x's or the y's in this problem, and we're going to go for the y's. So write down the two equations, 3x plus y is equal to 13, 2x plus 3y is equal to 4. You should number them. Number the first one obviously 1 and the second one number 2, so then you can refer back to them. Now the idea is that we have to try and make the y's the same. So the easiest thing to do, if you look at this is just one y. So in order to make that the same as 3y, we're going to multiply the top one by 3. So 3 times 3x gives me 9x, 3 times y gives me 3y, which is what I wanted, and don't forget to do 3 times 13, and that's the most common mistake that people forget about the last term. We're not going to do anything to the second one, so we'll just write that down again. But we notice now that the 3y's are the same. Now, the signs in front are both positive. So if they are both positive or both negative, i.e. the same, then you need to subtract. So draw a line underneath here, and then you do 9x minus 2x, which gives you 7x. 3y, take away 3y gives you nothing. That was our idea of doing that. And then 39 minus 4 will give me 35. So now you've got 7x is equal to 35. You have eliminated one of the variables, this one, in this case y. So dividing by 7, we can find that x is equal to 5. Now what we need to do, we've got a value for x, we need to find the value of y. So what we do is we substitute into equation 1 to find y. Or you could do equation 2. And what we do, instead of x, we now replace that with a 5. So we get 3 times 5 plus y is equal to 13. 3 times 5 is 15, so we get 15 plus y is equal to 13. We subtract 15 from both sides. We're going to get that y is equal to 13 minus 15, which is minus 2. Right, to check that we're correct, we can check in 2. So we can put our value of x in and our value of y in, and check when we do the sum that we actually get 4. So check in equation 2, and if you've used 1 here you must use 2. If you've used 2 here you must use 1. So 2 times x, which is 2 times 5, plus 3 times minus 2, which gives 10 minus 6, and 10 minus 6 is 4, and that's what I wanted it to be, so we're okay. So we can say that the answer is x is equal to 5, y is equal to minus 2. Now what are we doing when we are solving simultaneous equations? So let's look at this GeoGebra app, and the GeoGebra app, I will put the link into the notes of this video. So go into the GeoGebra app, and then let's make the coefficients the same. So a is 3 because it's 3x. B is 1 because y, and C is 13. Okay, and then the second one, x is 2, so D is 2, and y is 3y, and the last term G will be 4. Okay, and we can see what we've done. What this represents is these are two linear lines, two straight lines, and they meet at a set of coordinates where x is 5 and y is minus 2. And these are the solutions of this simultaneous equation. Okay, so you can see how this applet works, so it might help you when you perhaps are doing an exercise to check what you're doing. Right, let's go to the second one, which is 5x plus 3y is equal to minus 1, and 7x minus 2y is equal to minus 20. Right, here we have to multiply. If I'm going to eliminate y, you have to make that decision. So we're going to make the coefficient, the number in front of y is the same. So in order to do that, I'm going to multiply the top one by 2, because that will make that 6, and the bottom one by 3, which will also make that 6. So labeling 1 and 2 again, multiplying the top one by 2, so every term, 10x, 6y, minus 2, 2 times minus 1, and then the bottom one we're going to multiply by 3, 3 times 7, which is 21x, 3 times minus 2y gives me minus 6y, and then 3 times minus 20 is minus 60. Now, we've got the same number, but the signs are different. Now, when the signs are different, then you add using this method. Because if you do 10x plus 21x, you're going to get 31x, and then if you do 6y plus minus 6y, you get nothing, so you've eliminated that. And then minus 2 times plus minus 60 gives minus 62. Dividing by 31 will give that x is equal to minus 2, and then we do exactly the same as we did the last one, so we're going to substitute into equation 1 to find y. So we're going to have 5 times minus 2 plus 3y is equal to minus 1. Be a bit careful because we've got some negative signs here. So we've got minus 10 plus 3y is equal to minus 1. So adding 10 to both sides will give me 3y is equal to minus 1 plus 10, which is 9. And then dividing by 3, we're going to get that y is 3. We should check in the one we didn't use. So we're going to check in 2. So it's 7 times x, so it's 7 times minus 2. Minus 2 times 3, which gives minus 14, 7 times minus 2, minus 6, minus 14 minus 6 gives me minus 20, which is what I wanted. So it's correct, and therefore I can say that x is minus 2, y is equal to 3. And again, we can look at the GeoGebra app to see what we've done. So the first one, A is 5, B is 3, and C is minus 1. These coefficients go from minus 20 to 20. And then the next one, D, is 7 and minus 2 and minus 20. Okay, and again we've got two straight lines, and we can see they meet at the coordinates minus 2, 3, x is equal to minus 2, y is equal to 3. Again, this GeoGebra app is in the notes of the video. Okay, so we see x is minus 2, y is equal to 3. Okay, so this has been a video to show you about solving simultaneous equations, and then seeing what that actually means using graphs as well. I hope you've understood, and I thank you very much for watching.